Okay, let's keep moving with part 2 here. It says, what is the sum of these two terms? And we have negative 6x to the fourth plus 11x to the fourth. So what we do is the first thing we do is we check the like terms. Now they're going to kind of step you through it here. So let's just work through number 14. It says circle the like terms and underline the coefficients. Okay, well, this is negative 6x to the fourth and 11x to the fourth, and those are like terms because they're both x to the fourth. Remember, they have to have the same exact variables to be like terms. So it said circle the like terms. Now then it says underline the coefficients, and I'll do those in red. The coefficient is negative 6 and the coefficient is 11. So if I'm going to simplify this expression, basically what you're doing here, now they've kind of broken it down for you more than you really have to, but to try to get the point, since they both have x to the fourth, essentially you're going negative 6 plus 11, and you're adding that together, right? Negative 6 plus 11 is positive 5. So the answer is 5x to the fourth. Simplified right there. That really should be review for us. And then it said find the difference between these two terms. They broke them out here. So first thing we need to check is, are these like terms? X squared y to the fourth, x squared y to the fourth. Yes, they are like terms. So I'm going to circle them because it said to circle the like terms. And it said underline. I'll just keep my blue here. There's an underline. The coefficient is 2 and the coefficient is 7. So what you're going to do is go 2. Now they changed it to plus, so we're going to have to make that negative 7. And then they just kept the variables right there. You have 2 plus negative 7, and that is negative 5 right there. Okay, so that's how you add like terms. It's going to be important that you can identify like terms, and when you have them, you can add or subtract them. But if they're not like terms, you cannot add or subtract them. Really important chart right here. We'll talk about it more in class. A polynomial can be named based on its degree and number of monomials that it contains. Now let me explain. I clicked on my shade here so I can try to break down what it is that's happening. What they're doing here is they're starting with this column right here. I'll just call that column 1, polynomials. Well, the number 6, like we talked about earlier, I'll call this the second column right here. The degree of any number is 0, okay? So the name of that, anytime you have a number, is a constant because it has one term and it doesn't have a variable. And then we can also name it by the number of terms, and that is a monomial, just like we talked about. Even though it doesn't have a degree, it is a monomial. All right, going down, okay, this polynomial, 5x plus 1, well, that degree, the highest degree on that of those monomials, that monomial right there, the 5x, that's x to the power of 1, that's a first degree polynomial. Now, the name that we call that is linear because the highest exponent is 1, and it's a binomial because it has two terms, one term, two term, right there. This stuff I'm going to go over in class. I just want to talk you through it briefly right here. Now, this third one right here, this polynomial, 4x squared plus 7x plus 3. Well, notice its degree, the degree of this polynomial, is 2. So when we find the degree of a polynomial, we take the highest degree of all of the terms of the monomials. 4x squared is the highest degree. 7x, that's the first degree. So we take the highest degree and we call that the degree of the polynomial. Second degree polynomials are called quadratic, and if it has 3 terms, we call it a trinomial. All right, so we'll go over this in class. It's a lot of confusing things, and I can break it down better for you when I have a little more time, I think. And then let's move on to the next section, and like I said, we will talk about that stuff a little bit later, but I'll go ahead and talk you through problem 3 here. It says, write 2x minus 3 plus 8x squared in standard form, and what is the name of the polynomial based on its degree and number of terms. Okay, a polynomial can be classified based on degree and number of terms. Kind of hit that quickly in the previous one. Like I said, we'll talk about it in class as well. Okay, so this particular polynomial, it says write the greatest degree term. Well, the greatest degree term is 8x squared because that term has the highest power monomial. It's 2. Okay, then what's the next less degree term? Would be 2x, because that exponent is a 1. And then the least degree term is a 3. So that's called standard form when we rewrite the exponents of the variables greatest to least. That's standard form, and you will have to do that. So when you're asked to put it in standard form, you put it greatest to least by powers of variables. Highest variable goes first, and then you just work your way down. Number 19 says circle the name for the polynomial based on its degree. Well, you really have to go back to that chart here. These are the degrees, and these are the name using the degrees. And I believe it was power of 2, and the word for power of 2 is quadratic. All right, so since the highest power is 2, that's called quadratic. Right there. It says circle the name of the polynomial based on the number of terms. Well, there's 1 term, 2 term, 3 terms. That is a trinomial. So this is a quadratic trinomial. Now write the combined name. It's a quadratic trinomial. Quadratic trinomial. That's what that's called. All right, well, the other thing that we have to do in this chapter is we have to be able to add the polynomials. All right, we have a nice little equation here. I'm not going to read through it just because they went ahead and basically what they want us to do here is add these two polynomials. So I just want to deal with that first. They just put a nice little application concerning vegetables. It says that if you're going to add these polynomials, all right, you're adding this polynomial up here plus this polynomial here. All right, so to do that, what we've done here is we've rewritten the problem on the paper just like that. All right, and then what I'm going to do on the next line is I'm going to just look for like terms here. In fact, I'm going to put my shade up here. All right, I'm going to put it up like that because I like to do. In fact, I'm going to change back to my big screen there. That doesn't change much for you. Take a look at this line here that it's pointing to. Here we have negative 12x to the third. All right, I'm going to look at x to the 2 and ask myself, is that a like term with negative x to the third? It's not, so I'm going to put 2 lines under that one, if you can squeeze that in there. And then it's minus 241x. Well, that's not a like term either, so I'm going to try to squeeze in 3 lines there because it's different from these 3. And this 447, that doesn't have a like term, so I'm going to squeeze in 4 lines. I don't know if I can get them in there. 4 lines there. Okay, now that is all being added to 14x squared. Now 14x squared, that matches this one right here, and that's 2 lines, so I'm going to put 2 lines there. Minus 14x, that needs 3 lines. You see why? Because it matches this one right here. And this 1545, that gets 4 lines because it matches this one here. So in the next line, what they're doing is they're putting the like terms together. All right, negative 12x to the third, that didn't have a match. See how they just have the parentheses there? Plus, now notice they have parentheses here around something, and x squared, or 14x squared. Well, there's 14x squared. 106x squared is what matches that there. So we wrote that there. 14x here, that had a like term of 241x. Okay, so notice they put the parentheses around that. Plus, and then this one was just a number, so we need the other like term that matches that. So what we've done here, what they're trying to show you is you look for like terms when you add polynomials together. You look for like terms. Look for like terms. And then you just, oops, I spelled terms wrong, sorry. Then you just add the coefficients appropriately. Well, negative 12x cubed does not have a like term. 106 plus 14, all right, that's pretty simple. Add those together. 106 plus 14, that would be 120. And don't forget to put x squared. And then the next one is this one, 241 minus 14. and we add the, I'm sorry, it's negative 241 minus, that was supposed to be negative, sorry about that. That was negative there, and that should be negative there. Negative 241 minus 14, so think plus negative. So that would be minus 241 plus 14 would be 255x. Plus the last one, those two numbers there add up to 6022. Okay, so the polynomial that represents those two polynomials added together would be negative 12x cubed plus 120x squared minus 255x plus 6022. And that's the basic idea of adding polynomials together. We're going to do another one in the next video. I need to stop this because I'm getting a little bit long, so there will be one more video and then we will wrap it up.